Okay, thank you, Vinita. We thought that we might finish off the presentations today by giving a brief overview of how environmental historians think about the climate and how climate might frame their research. So just want to begin off with an assertion, I suppose, that science is objective, isn't it? And to say that the way we think about our world is inherently politicized. And I could go back over Antonia and Rob's presentations in an interesting critique in that way. And we've probably been taught to think that science is about facts and facts are neutral and objective and right, right? Well, of course, the answer is wrong, or at least right or wrong may be as much a matter of culture as it is of scientific certainty. Let's take the map of the world for an example, more precisely the Mercator projection of the world, which greatly distorts the sizes of countries near the poles, e.g. Africa and Greenland look the same size, when in fact, of course, Africa is about 14 times larger than Greenland. It is a great episode of anyone's an aficionado of the West Wing, where they have a little scene about this. And it conversely makes everything nearer to the equator look smaller. These maps are usually cropped to include much more of the northern hemisphere than the southern one. And of course, the map is centered usually on Europe because of the Greenwich meridian, which separates zero longitude, which separates east from west. So how much of our image of the world and our place in it is fundamentally distorted by such maps? The sense of importance, in a sense, influenced by impressions of size and location, i.e. that is, there is a cultural bias in favor of Europe and the neo-Europes, by that I mean North America, Australasia, etc., in comparison to non-European nations. And what's true about maps and how we see the world is equally true about climate and the way we talk about it. So what I thought I'd do this afternoon is say a few words about what is the difference. First of all, it's sort of like a 101 in climate history. What is the difference between weather and climate? How has climate changed in the last 500 years and how do we think about it? What caused these changes in climate? Did changes in climate have an effect on society? And what does climate change mean today? And then come back to this question about how we think about climate is perhaps inherently politicized. So first of all, what is the difference between weather and climate? Well, the difference between weather and climate is weather is about short-term, minute to month changes in the atmosphere, and climate is a description of long-term patterns of weather in particular areas. And scientists often define climate as the average weather for a particular region and time period over, say, a 30-year measure, measured by looking at averages of precipitation, temperature, humidity, a lot of the things, of course, that both Antonia and Rob have been talking about: sunshine, wind velocity, phenomena such as fog, frost, and hailstorms, and other measures of the weather that occur over long periods in particular places. If we look at how climate has changed over the last 500 years, well, there's certainly been worldwide climatic variations over the last half millennia, most notably the moderate cooling of the climate between 1550 and 1850, usually referred to as the Little Ice Age, and then noticeably the rapid warming post-World War II, which we popularly refer to as climate change. With the Little Ice Age, it's best described as a period of significant variability in climate rather than consistent changes in overall average climate, with prolonged multi-year cold spells, often quite specific to particular seasons, but with a general moderate cooling of climate. It's approximately 0.3 degrees colder during this period than the centuries before, between 1000 and 1400. And it's about 1 degree colder, or slightly less than that, than the temperature in the late 20th century. With climate change, we're talking about how the planet's average surface temperature has risen by at least 1.1 degrees centigrade since 1900, and a lot of people would say it's a lot more than that. How the oceans have absorbed much of this increased heat, with the top 700 meters of the oceans warmed by about 0.2 degrees in the last 50 years, and how most of this warming has occurred in the last 35 years. 16 of the 17 warmest years on record have occurred since 2001. Not only was 2016 the warmest year on record, but 8 out of its 12 months were the warmest on record for those respective months. And now 2020 is actually, I believe, tied, though I don't know, Rob would probably be able to say how you can have a tie between 2016 and 2020 as being the warmest year. Rising temperatures are fueling longer and hotter heat waves, more frequent droughts, heavier rainfall, and more powerful storms. So how do we go about measuring it? Well, the most common climate observations are of temperature and precipitation, but there are other climate variables, including humidity, wind speeds, direction, air pressure, cloud cover, and solar radiation. We usually divide this data between the instrumental, which is what mostly Rob and Antonio have been talking about. This is direct data, beginning with simple records based on thermometers, barometers, and rain gauges, to, of course, the sophisticated instruments and satellite scientists use today to measure climate parameters. But there are also proxy or indirect data. These can be long-term historical documentary records, as well as more proxy climate data, things like tree ring densities, sediment cores, ice cores, and coral reefs and such like. The problems with this data is that the instrumental data only extends at a maximum probably for the last 250 years, and is disproportionately about historical data written by or to do with Europeans and neo-Europeans. And I think Rob's graphic representation at the end clearly showed how that was the case. So what are the causes of these changes in climate? Well, the Little Ice Age is an unusual period, in recent climate history, as regarded as occurring really before the influence of large-scale human activity on temperature and climate. And climate change itself is then largely recognized as a product of human activities, the burning of fossil fuels associated with the Industrial Revolution beginning in approximately the middle 18th or early 19th century. So if we're looking at the sort of natural causes of climate change, well, this is a subject of active debate and includes several possible variables: changes in solar output by the sun associated with the Maunder minimum between 1645 and 1715, when sunspots became exceedingly rare; changes in oceanic circulation, especially to do with the Gulf Stream. One might say, actually, being in the UK at the moment, I think we're very much aware of that, at least on a weather basis. And even volcanic activity, especially in the 19th century. We have the eruptions of Tambora in Indonesia in 1815, the so-called the year without a summer in Europe, and Coseguina in Nicaragua in 1835. If we're talking about human causes of change, well, research definitely indicates that natural causes cannot explain the rapid warming since the mid-20th century. And it's extremely likely that human activities have been the dominant cause of recent warming. Since the Industrial Revolution, circa 1750, human activities have contributed substantially to climate change by the burning of fossil fuels. And you can see the graph there on the right-hand side clearly illustrates that. The greenhouse gases have risen by approximately 260%, especially carbon dioxide, in turn increasing the greenhouse effect in the atmosphere, that is, or slowing or preventing the loss of heat to space and causing the Earth's surface temperatures to rise. However, the story is probably not quite as clear-cut as sometimes the narrative is made out to be. Some historical geographers now argue that the neotropical lowlands of the Americas went from being a net source of carbon dioxide to the atmosphere before Columbus and the Spanish colonization of the Americas to becoming a net carbon sink for several centuries following that Spanish conquest. The Spanish conquest and settlement of the Americas after 1492, as we're probably all aware, led to an enormous demographic collapse with over 90% of the indigenous population dying, and the sudden abandonment of cultivated land in the 16th century and the dramatic decrease in human-ignited fires led to the wholesale reforestation and to augmentation of woody biomass in the Americas. This significant increase in carbon sequestration and decline in atmospheric CO2 may not have caused the Little Ice Age, but it probably measurably amplified its effects. So what did these changes in climate, what effects did they have on societies? We're talking about the Little Ice Age. Well, the generally colder weather of the cooling climate between 1550 and 1850 had significant impact on some societies. And though the effects were varied considerably from place to place, we can, I think, make some generalizations here. First of all, the most, and perhaps the most important and primary, was in food and food production. One of society's key sensitivities to climate is food production. For instance, the growing season. Hubert Lamb argues that the growing season might have changed by 15 to 20% during the Little Ice Age. And the example of England's growing season may have been shortened by 1 to 2 months compared to today, which is obviously very significant. Grain prices increased, affecting particularly those who had to buy bread on a daily basis. The types of crops that were grown changed or were varied. The greater resistance of the potato to withstand cold seasons led to the widespread adoption of this crop by farmers throughout Europe, particularly in Ireland, with, of course, very important consequence effects in the 19th century. The height at which agriculture could be practiced changed. Many farms located at higher altitudes in countries like Norway had to be abandoned. And for instance, in that country, the 1665 total grain harvest was only about 70% of that it had been in around 1300. So again, a significant decline. There were advancing glaciers in the Alps and in Northern Europe, which overran towns and farms, a decrease in livestock, insufficient hay to feed the same number of cattle through longer winters, leading to smaller herds. And even fishing in Northern Europe was badly affected as cod migrated south to, and other fish migrated south to warmer waters. The effects on societies, however, were varied. In isolated regions like high alpine areas of Switzerland or the highlands of Scotland or Iceland, these longer winters and cold springs and harvest rains raised grain prices and caused local famines. And we get a series of these during the Little Ice Age. In fact, it became impossible to grow grain in Iceland, and even the hay crops failed there at times. However, countries like England and the Netherlands, with much more diversified agriculture, where land reclamation had been considerable, and where they had good international trade networks, coped much better and were able to import the food when harvests failed. And so, again, very much historically particular to the society and country. Other influences on society, well, health. Antonio was talking about medical records. So, I mean, health was significantly affected by cooler climates during the Little Ice Age. Dearth and famine killed millions, and malnutrition weakened immunity to illnesses such as influenza and bubonic plague. So you get a knock-on effect there. During most of the 1550s, deaths in Northern Europe outnumbered actual births, which is interesting. And in 1693, the famine due to harvest failure led to millions of deaths in France and surrounding countries, so widespread famines at certain times. Along with famine often comes war and social unrest, and there are definitely links made between the Little Ice Age and major historical events. Lower agricultural production and inflated grain prices helped certainly fuel the 30 Years' War between 1618 and 48 between Protestants and Catholics in Central Europe. And 2 decades of poor harvests brought drought, cattle disease, and skyrocketing bread prices at the close of the 18th century have been blamed for kindling or helping kindle the French Revolution. And amongst the readings for today, and I think Antonio or Rob already mentioned him, is Geoffrey Parker's work in that respect. Very interesting. Apologies for the slide here, but it's the best one I could find. Those observant amongst you will have noticed that most of the examples that I have been talking about have been in Europe and the Neo-Europes. So what effect did the Little Ice Age have on the rest of the world? And we have much less evidence and considerably less research in that respect. In North America, for instance, the Little Ice Age was different. While the 17th century was the coldest in Europe, it was actually the 19th century that was the coldest in North America, exactly when the Little Ice Age was actually waning in Europe. About Russia and China, well, there are some long-term documentary evidence providing different pictures of temperature variations to that of Europe. And in China, but with little evidence of really distinct cool periods during later centuries of the millennium. And in the Southern Hemisphere, the evidence for the Little Ice Age is even much more diffuse than that and much more hard to find. So really, when we're talking about the Little Ice Age, this really was a phenomena that affected Europe and other neighboring regions around the North Atlantic more than it affected the rest of the world. When we get to climate change, of course, things are different. Since the last ice age about 11,000 years ago, the Earth's climate has been relatively stable at about 14 degrees centigrade, but since the 1950s, the average temperature has begun to increase considerably. This is due to industrialization. In fact, this is a period that the atmospheric chemist Paul Crutzen now calls the Anthropocene. Again, some people, the dates of when that begins is highly debatable. But it was also due to demographic growth. It's an unfortunate consequence that humans fart, and fart is a greenhouse gas. And the more humans you have, the more the greenhouse gas is given off into the atmosphere. The same with livestock, particularly. The more livestock there are, this also contributes significantly to greenhouse gases. And to deforestation has, of course, been another factor with the depletion of forested areas across the globe. climate change means large-scale, long-term shifts in the planet's weather patterns or average temperatures. And the definition here I put up here from the Intergovernmental Panel on Climate Change. Climate change can be defined as, quote, a change in the state of the climate that can be identified, i.e. using statistical tests, by changes in the mean and or the variability of its properties, and that persists for an extended period, typically decades or longer. So what does climate change mean for us? Well, in terms of environmental changes, we're talking about higher average temperatures, changing rainfall patterns and more heavy rainfall events, changes in seasons starting either earlier or later, sea level rise, melting permafrost, retreating glaciers all over the world, the Alps, Rockies, Andes, Himalayas, etc. Arctic sea ice declining but increasing in the Antarctic, ice sheets shrinking at an accelerated rate both in Greenland and Antarctica. But there are equally societal changes that are just as dramatic. First one might be the increasing shortage of fresh water, and this is going to become an increasing source of conflict in the decades to come. Sweeping changes in food production, more deaths from floods, storms, heat waves, and droughts, plant and animal extinctions as habitats change faster than species can adapt, the spread of disease, increases in malaria, waterborne diseases and malnutrition, greater human migration, and we can see that already very in large scale human movements, increased social unrest and war. I think there's been some very interesting work which has been measuring actually climate and actual number of conflicts. And some people talk about resource wars, water wars as being one of the effects of this. And I think the important thing to point out here is that poorer countries, which are perhaps least equipped to deal with these kinds of rapid changes, are the ones that are suffering the most. And that sort of really brings me back to the notion that I began off with, which is to thinking about climate as inherently politicized. And apply that really to climate. If we have to divide the climate of, say, the last 1,000 years into discrete periods, this is usually done in terms of the medieval optimum or warm epoch between around 1100 and 1300. And then we have the little ice age between 1550 and 1850. And then perhaps we could talk about climate change post 1950. But we have to ask whose climates are these periods based upon? And perhaps a giveaway clue is the word medieval, a historical period that really is only relevant to Europe and to nowhere else in the world. So like so much of the way human history has been depicted, it's rooted in a historicism or stages in historical development along lines of what the Indian historian Amit Chakravarti calls first in Europe, then elsewhere. And with all the associations that, like the Mercator map projection that I discussed at the beginning, have as an effect. Okay, and that's the end of my talk there.